Hi, good day to you and welcome to my channel where I tutor you in science for free. The topic in this video will be kinematics. And kinematics is the study of movement and how do we quantify it through space and through time. So before we dive into that, we are going to cover two new vocabulary in physics. We call scalar and vector. Scalar are quantities that have only a magnitude. Magnitude means a numerical value. Something that, let's say, for example, an item is 4 kg. The magnitude is 4. Every now and then, there can be certain places having a earthquake of a magnitude of something on a Richter scale. So magnitude is just a numerical value, don't think too much about that. And vector quantities means they have both the magnitude and a direction involved. So scalar quantities are these, and the vector version of distance will be displacement. It is always important to note that the positive direction must be defined to understand where is the positive displacement. So if you are going in the opposite direction, it is a negative displacement. It's like getting an orientation of where is the front and where is the back. So don't get too confused and now or too emotional over this vocabulary right now. So you just need to know that scalar means numerical value, magnitude, and vector means magnitude and direction. And so the vector version for speed will be velocity deriving from velocity. Changes in velocity over time will be acceleration. Moving energy through a certain distance will be called force. So talking about the first two quantities over here is the distance and displacement. What's the difference? So distance traveled can be a curved path, but vector displacement is always the only measured in the straight line. So it's just the origin to the destination. Then next we'll cover is speed, and speed has a formula of this. Okay, so it's been covered before in your earlier education, not very interesting. So we move on to average speed. Average speed is the total distance traveled over the total time taken. An example is it's like when you walk to school, you could have been walking in different speed at different points in time, or cycling to school. You take an average of the total distance covered over the total time taken. In comparison, velocity is the one with a direction. So we use the displacement. So velocity would mean displacement over time taken. So just know that the difference between distance is the one that actually is traveled by the object. So let's take a look at this example. A car travels forward 7 km and back 5 km in the span of 20 minutes. The speed would be this, but the velocity, very different. It will be this because it takes into consideration only the start and the end. And next will be acceleration. Acceleration means the changing of speed through time. Some of the most common examples will be the start of a race. The first few moments are slower than when the athlete reaches top speed. Another example will be car. The beginning moments of the car moving will be slower. So acceleration is defined as the change in velocity over time taken. So you use final velocity minus initial velocity divided by time taken. And the symbols are as such, v minus u over t. If you do not know what it means, I always recommend my students to write out in the actual words. A lot more time consuming, but it makes a lot more sense. And your mind won't be swayed to what values to be placed in which position. Objects can have uniform acceleration. So the rate of change of velocity would be the same, and also non-uniform acceleration. So same car at rest, reach velocity of 12 meters per second in within 4 seconds. So first you do extraction, then you put in your formula, sub everything, and bam. So very simple maneuver. The same example can be said for deceleration. An object is traveling at 8 meters per second, changes to 2 meters per second in a span of 10 seconds. So same, do extraction, throw formula, sub in, and bam. And in this chapter, one of the common skill sets is to draw the graphs of motion. So first we explore the easier one, which is the displacement time graph. So if something is at rest, it is supposed to be a straight line. It depends on where in position you want it to be. If it is traveling at a constant velocity, it should be a constant gradient. And why is it constant gradient? Because gradient means rise over run. The rise is your displacement, your run is your time. So displacement over time gives you your velocity. So if the gradient is the same, velocity is the same. Increasing velocity, so the gradient will change. Decreasing velocity, the gradient will get more gentle. So the next one will be the velocity time graph. If an object is at rest, it has to be at 0, traveling at constant speed, straight line above 0. Uniform acceleration will be a constant gradient. Why constant gradient? Because gradient means rise over run. Rise means your velocity over your time taken. Here it is talking about the change in height. So final minus initial velocity over time taken is the exact formula for acceleration. So the same can be said for uniform deceleration. Increasing acceleration, gradient increases. Decreasing acceleration, the gradient decreases. So displacement time graph and velocity time graph is a little bit different. So it's easy to find the distance traveled for displacement time graph. You just have to count the total length covered by the line, but it's a little bit complicated for the velocity time graph. You need to find the area under the graph for your velocity time graph or your speed time graph. Okay, and why is it area under the graph? Because distance equals speed times time, or displacement equals velocity times time. So if velocity times time, that literally translates to area under the graph. So it can be of various shapes like rectangle, square, triangle, trapezium. You need to be familiar with the formulas involved. Some tips would be to cut up the graphs into different portions and you count them individually and add them all up together. So comparing speed time graph against velocity time graph will be that velocity has a direction and it can go in the negative direction, but speed time graph just talks about how fast an object moves. So over here, when you throw a ball up in the air, momentarily it's going to stop and come back down. So for a speed time graph, it will look like that because the point at 0 means the ball has reached its maximum height and it comes down again and gains in speed. But it's a little bit different for the velocity time graph because coming down is the opposite direction. That's why it touches 0 and goes into the negative zone. Okay, next we will be talking about gravity, specifically acceleration due to gravity. Earth exerts a certain amount of force onto all objects on the Earth and they all will fall at about 9.8 meters per second square. But in secondary school level, it's commonly agreed on to use 10 meters per second square for easier calculation. So if you drop an item from a high place, it gets faster and faster. It falls faster and faster towards the center of the earth or until it hits the ground. But if an item, say for example a piece of paper or a feather, is being dropped, they drop a lot slower because of such thing called air resistance. Because of its shape, it is heavily influenced by the air around it. And if you remove all the air, all items will have the same acceleration. So a parachute uses this principle of air resistance. Air that is present in the atmosphere will always oppose falling objects falling through it. So the wide area helps to catch a lot of air and exerts an outward force on the falling object. And as a result, objects, if left to fall for long enough period of time, they can reach terminal velocity. Terminal velocity is different for different objects. The heavier the object is, the terminal velocity will be a lot higher because as the object falls through the air and accelerates due to gravity, it gets faster and faster. The air resistance that it experiences increases. You can imagine that like you are riding a bicycle. If you ride it very fast, you can feel the wind. If you ride it slow, you feel less wind. So it's the same, just that it's vertical. And once an object experiences sufficient amount of upward air resistance, the upward force is equivalent to the downward force. We would say that the object has reached terminal velocity, so it's falling at the constant speed. How this works is the weight of the object will always remain constant and it will fall until it reaches the speed whereby the air resistance exerts the same force as the weight. That is, the upward force equals downward force. So the graph will look like that. It has a curve and then it plateaus to a flat line. Okay, so now let's look at some questions to further deepen our understanding. Note that vectors add up together and to form a resultant vector. Resultant vectors are drawn with double arrows. So usually questions like to ask if an object goes in this direction and being affected by wind in this direction, the resultant direction will be the joined up one, which is this. So downward force, a weight, is also a vector. Weight is defined as mass times the downward acceleration, which is gravity. So mass times gravity. So in translated to another form is mass times acceleration, which is force. And acceleration has direction. So force equals vector, weight also equals vector. You will learn more a little bit on forces in the coming chapters. Talking about addition of vectors, if there are a couple of forces acting on a certain object and the certain object is stationary, the vector forces must close back in a loop. Recall that vector quantities only take into consideration the origin and the destination. So if the destination is the same point as origin, which means to say it's not moving, the vector diagram has to be a closed loop, either clockwise or anti-clockwise. So a nail is on a wall being pulled by a string. The nail itself has a certain amount of weight, so the force exerted by the wall will be this resultant one, because everything must close back as a loop. And do also note that vectors are just arrows in a certain direction, and the length of this arrow when you draw them has to be to scale to its magnitude. So if it is a large force, it has to be longer. On exercise, if it is good to use, like say, okay, maybe 4 Newton, you draw as 4 cm, 1 Newton draw as 1 cm, that kind of ratio. And these arrows can be moved around, so it's good to imagine that you can move them around, draw them up into a clockwise loop or anti-clockwise loop. It's up to you. So similarly for this example, if 6 Newton upwards, 3 Newton to the left and 3 Newton down, you can draw it in this manner to its correct proportion. Then you can find very easily what is the resultant movement. So same, object falls through vacuum. Acceleration is constant, commonly accepted in secondary school as 10 meter per second square. Velocity, the downward speed, would be increasing. So MRT stations, distance is 960 meters, accelerates uniformly for 16 seconds, constant speed of this for a time of t, decelerates uniformly for 18 seconds. So what's the value of t? So distance is given, you need to work backwards. A good way is to draw the graph, remove the triangles, and then divide by the speed, you will get the time taken. So this is how to work this question. Same, if it moves north at this velocity, then at this time it starts to change its acceleration to -2 meter per second square. You need to be sharp to understand that it's going in a negative direction, it's coming backwards. Then at t equals to 15, what would it be? Where would it be going? So a good tip is to draw a graph that will look like that and have a gradient of this. And note that it takes 17.5. So at t15 it's still in the north zone. Sometimes questions may ask you in terms of to explain certain things. The vocabulary and language use has to match the situation that is given to you. So if a stone is being dropped, the initial acceleration will be constant. Then after that, the two forces acting on it, its weight downwards and the air resistance upwards, will act on the stone. Stone speed increases. Air resistance experienced will also be increased, the upward force. And since weight of the stone stays constant, the downward resulting force will be reduced. Therefore, the acceleration will be reduced. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!